So I guess I am audible. Let me yeah, increase the volume. So hello everyone. I am back with another test discussion, and today I'm going to discuss these three questions: question one, question two, and question three of this Algo mock test based on internship, or you can say placement OA. So without wasting much time, let's get started with the problem one. So this problem is string compare, right? So let's read the problem first. Alice and Bob have a keyboard that can type lowercase English alphabets. The keyboard also has a backspace key. Okay, when the backspace key is pressed, the last character from the string is removed, and if the string is empty, nothing happens. Okay, nice. So Alice and Bob are have both typed a string in their respective computer with their keyboards. Okay, when they press backspace key, this hashtag is was inserted into the string. Okay, and we want to know whether their strings are equal when it is typed into a text editor or not. Okay, so let's try some test cases. So in this first test case, first of all, the constraint over the length of strings s and t are these n and m are up to 10 to the power 5. So let's first try this test case. The string s is a hash b, right? String t is hash a, again hash b, right? So let's evaluate what will be the string s after typing. So initially the first character was a, right? So on the board, when Alice was typing, she typed a, then she pressed backspace. After pressing backspace, a was cleared, and again she pressed backspace as the string is empty, so this would not affect anything. After that, she typed B. So the final string of Alice is B. Let's now evaluate the final string of Bob. Bob first pressed the backspace key, which will not affect anything. Then he pressed A. Okay. After A, he again pressed backspace. So let's remove A. And after that, he again pressed B. So the final image of both these strings are S. The final string S will be B, and the final string T will be B also. So we can see that string S and T are equal. So in that case, we can say that yes is the correct output. Otherwise, it should be no. So let's now see how we can approach to this problem. We have to compare both the string. We have to complete this function. In this problem, uh, I will use stack. Why I am using stack? Because if I use string, let's say I am using string, new string str, whenever I am getting a character which is not hash, I will append this character to the string. Let's say if I am talking about this s, so initially my pointer is at this point a, so a is appended. After that I am at this hash means backspace, so I have to remove this. You can see that again and again we have to remove characters and push characters at the end. We can use string, but in this problem I'm going to use stack. So let's see how we can do this problem using stack. So let's try to build an algo for this problem. Uh, let's say I'm using a stack STK. Whenever I'm getting a non-hash character, I will append this. So if character is not equals to hash, append, or we can say push character to stack, right? If the character is hash, that means I have to remove the last character, which will be at the top of the stack. So I have to do stack.pop if stack is not empty, right? If stack is empty, then this hash or backspace key will not affect anything. So at the end of the iteration, or we can say the traversal of both the strings, I can have two stacks, and I can retrieve the string using that stack. Let's see how. Let's let's check this test case now. Test case 2. So the string for this test case is s is a hash hash b, a hash hash b. Let's see the t. So t is hash a hash c. Okay, so let's now build the stack 1 and stack 2. For string s, I'm creating the stack 1, and for string t, I'm creating the stack 2, right? So initially I have to traverse this string s. So a is not non-hash character, so I have to append this uh, in the stack 1, a. Again, hash. I will check, as this character is hash, I have to check whether the stack 1 is empty or not. So this stack 1 is not empty, so I will pop this a. Now I am again at hash, but in this case, the stack is empty, so this will not do anything. After this point, I am at b, so b is not hash, so I have to append this to stack. Let's now create stack 2 for this t. Initially, the first character is hash and stack is empty, so I don't have to do anything. Then a comes and a is non-hash, so let's push a. Again hash, pop this a. Again I am getting c, which is non-hash. So after after traversing both strings, I am having my both the stacks. Let's now retrieve the strings. So the final string s should be b after retrieving from the stack, and t should be c. As you can directly see that b is not equal to c, that is s is not equal to t, so the output should be no. So yeah, let's see. Yeah, let's now quickly discuss its time complexity and space complexity as well. As I am traversing both these strings, and the length of strings are n and m, so the time complexity for this problem is big O of, wait a second, big O of n and n plus m, right? And the space complexity for this problem is also big O of n plus m. I am doing this problem in linear time complexity. Let's now quickly code this problem. Yeah, this is the string compare problem. Okay, let's first store the string length. S dot length m is equals to t dot length, and let's create two stacks of character, stk1 and stk2. Let's quickly build the stacks for auto. Belongs to string s. If this character is not hash, let's push this character into the stack, stk1 dot push character. Else, that is the character is hash, I have to first check whether the stack is empty or not. If stack is empty, I don't have to do anything, so just continue. Otherwise, if stack is not empty, I have to pop, right? And after the stat, I'm having my stack 1. Let's quickly build stack 2 also. Auto character belongs to string t, right? I can copy this thing, stack 2, stack 1, and this is stack 2. After this step, I can retrieve my strings, and also I can compare the stacks also. If the stack are identical to each other, that means I will after retrieving the strings will also be identical. So I can directly check if stack 1 is identical to stack 2, then it should be yes. otherwise it should be false. Let's run this code. Yeah, it's accepted for sample test. Let's now submit this code. Also, as the n and m are up to 10 to the power 5, so the big O of n plus m will be at max 2 into 10 to the power 5, which will not cause me any kind of TLE or something. Yeah, it got accepted. Let's go to the problem 2 now. Problem 2 and problem 3 are quite interesting. Problem 1 was simpler. So let's quickly read this problem. In this problem, uh, we are given an array A. Okay, we are given an array A of size n, and every element is A of I is greater than or equals to 0, non-negative integers, right? And our task is to find rightmost non-zero digit in the product of array elements if it exists. Okay, and if it doesn't exist, I have to print -1. Okay, and the size of array will go up to 10 to the power 5. Nice. Let's quickly uh, try to solve this test case. So we are having this array 3, 23, 30 and 45. So first thing which that comes to my mind is, as the n is up to 10 to the power 5 and AI is up to 10 to the power 5 also. First thing that the first key observation for this problem is we can't do uh, product of all the elements normally. Like if I am having three elements A, B, C, I can directly do product of this whole array A into B into C. But in this case, I can't do this thing because if I do, if I am calculating the product of all these elements, the product can go up to 10 to the power 10 because each AI is up to 10 to the power 5 and there are 10 to the power 5 elements. So the worst case scenario, the product will be this product can go up to 10 to the power 10, right? And the integer bound values are up to 10 to the power 9 only. So this solution will not work. What I have to do is, let's check first for this test case, 3 into 23 into 30 into 45. So in this type of problems, there is no need to evaluate the whole product because it is asking just for uh, the last non-zero digit in the product. So you can directly see that as I am having 0 in this 30, so the final product will have at least one zero, at least one zero. That means, let's see the unit digits. 5, 3, 3, ignore this 0. So 3 into 3 is 9, into 5 is 45. So unit digit of this 45 is 5. So that's how I can relate something to this. So first let's discuss, let's try when I have to return -1. I have to return -1 if the product if there is no non-zero digit in the product of elements. This is the case when the product itself is 0, right? So I have to return answer value as -1 if the product of all the elements is 0. And product of all the elements can only be 0 if and only if there is at least one element which is equals to 0, right? So I can handle this type of cases separately. If there exists an element which is 0, that means the answer value will be -1. So I have discussed this case. Let's now uh, try to evaluate the final value, like the unit digit, not the unit digit, the rightmost non-zero digit, right? So for this type of evaluation, I have to remove zeros at the end. Let's take an example. Let's say I'm having this kind of example: 2, 4, 25, 5. Let's say I'm having this type of array. Overall product for this array elements, for all these elements are 2 into 4 into 25 into 5, which is equals to 2 into 4 is 8, 8 into 25 is 200, 200 into 5 is 1000. So answer for this problem is 1 only. There is no need to consider all this 0. So the key observation for this problem is, in the final product I have to remove all the zeros, right? And after removing all the zeros I have to return the the digit present at the unit place of the remaining number, right? How I can remove the zeros? Before removing zeros, let's now discuss how the zeros are creating, how zeros are coming in the final answer. In the product, I can only have zeros when there is a factor of 10, or let's say power of 10s. 10 is, I can like factorize 10 as 2 into 5. That means if I am having the prime factorization of all these numbers, I can represent these all these numbers as 2. I can represent as 2 to the power 1. 4 I can represent this as 2 to the power 2, and 25 is 5 to the power 2, and 5 is 5 to the power 1, right? Let's say in this case I am also having something like 35 also. So 35 I can uh, represent 35 as 7 times 5 to the power 1, right? So I can see that 2 is coming 1, 2, 3 times in prime factorization of all these numbers, whereas 5 is coming 1, 2, 3, 4, 4 times. So you can see that uh, the minimum of these two numbers is 3, which is because of 2. So I can club these 2 and 5 in pairs like this: 2 into 5, again into 2 into 5, again into 2 into 5. After clubbing all these pairs, I will be having 1 5 left over left. You can see that all these pairs will give me 10 10 10, that is 1000. That is, I can say the final answer is 5000 in, into 7 also, so 35,000. I have to remove these three zeros, right? And after removing I will be having 35, and the answer will be 5. So for doing this type of thing, what I have to do is I have to remove all these zeros, right? So for removing zeros, I have to remove the contribution of uh, minimum number of 2 and 5, the common part. So common in this 2 and 5 are 3. I'm talking about the frequency of these prime factors which are appearing in the prime factorization of all these numbers. So that's how I can somehow approach to this problem. Let's now discuss the algo for this problem. What I will do in this problem. The first step for this problem is, let's do prime factorization, and after doing prime factorization let's store the frequency of each prime factor, that how many times it is coming, right? After that I have to remove the contribution of 2 and 5 contribution of 2 and 5 which is common to both, right? So after that I have to remove the frequency of 5. Basically I have to update the frequency of 5 as frequency of 5 minus that common part, right? And frequency of 2 I have to update this as frequency of 2 minus the common part. After that I have already removed all these zeros, and I just have to calculate the unit the digit present at the unit place of the product now. So how I can do this thing? Let's start. So after doing this kind of steps, so let's say I was having this particular test case. Yeah. So after doing prime factorization, I know that this is just 2 to the power 1, this is 2 to the power 2, this is 5 to the power 2, wait, 5 to the power 2, this is 5 to the power 1, this is 5 to the power 1 into 7 to the power 1. So after doing prime factorization and storing the frequencies, I can see that frequency of 2 is 1, 2, 3, frequency of 5 is 4, frequency of 7 is 1 only, right? So I have to remove the common part. The common part between both these is 3. So I have to subtract the common part. So the final frequency of all these, frequency of 2 will be 0 and frequency of 5 will be 1. Right? So after doing this stuff, I will be having 1, 5 and 7 left behind. So the product of these two is 35, right? Okay. So the unit digit of this 35 is 5. How I can calculate this 5 from 35? If you can see, for calculating unit digit, just I have to do mod with 10. 35% 10 is 5. That's how I can do this problem. Let's first shift the question 3. Yeah. So this is what I have to do. So after doing this, I have what I can do is I can store a current product, or you can say the current modular product in this current value, which is initialized with 1, and after that I will like iterate in the map, or you can say the frequency vector. Auto it belongs to that frequency, and I have to update this current value for each prime factor, right? So for int j is equals to 0 to it dot second, that is its frequency. Yeah, I have to update this current value as current multiplied with it dot first. But after doing this, I have to take mod with 10 also. Why? Because I am interested only in unit digit. I'm not interested in the complete product. I am just interested in unit digit. As I'm doing this mod 10 again and again, so the instantaneous current value will be from 0 to 9 only. So this product will never go out of bounds. Okay. So after this step, I can return current value. So before coding this problem, let's quickly discuss the time complexity and space complexity for this algo. Let's see. Yeah, for prime factorization, uh, as you all know, the prime factorization of number n, it takes big of up to log n, but I have to do prime factorization for n elements. So in worst case scenario, it will take me big of maximum time, which is maximum value for this is 10 to the power 5. Okay, it will be big of maxi log maxi, where maxi is the max element of the array, and after doing this, this will cost me 1 for each particular operation. This is also big of one step. After doing this, I will iterate in this frequency map, which will go up to, this will combine go to big of n, So time complexity will be almost big of n, kind of linear, which is big of 10 to the power 5 almost, or something like this. Let's discuss about space complexity. I am storing frequency map, so it will go up to. So space complexity and time complexity will be linear for this problem. Let's quickly code this problem now. Non-zero digits. Yeah, hash include bits / stdc ++ dot h using namespace. Test cases or not, there is no test case here. Non-zero is equals to 1. There is no test case, so I do minus minus. I have to take an array as input. Let's take this array in input now. Yep. After this, I have to maintain the map. Okay, so unordered map where I will be storing the frequency of uh, frequency we be storing frequency of each prime factor. So prime comma frequency. It's now go each element to x belongs to array. Store the instantaneous value of x to y. So while y%2 is equals to 0, basically I am calculating, I am finding the prime factor. I am doing the prime factorization of this y, which is the element of array. Y should be divided equals to 2 and m frequency of 2 plus plus, or I equals to 3 and I into I should be less than equals to y, I plus equals to 2, because I have already take care of all the even numbers. Now I have to just check for odd numbers. If while y% I is double equals to 0, I have to divide this with I, and frequency of this particular I prime number I have to increase. And yeah, after doing this, if y is not 1, that means y is also a prime number. So let's increase the frequency of this y. So after this step, I have created this map. Let's now update the frequency of 2 and 5 to remove the zeros. So minimum is equals to min of frequency of 2 and frequency of 5. Yes. Okay. So if frequency of 2, subtract the minimum value again, 5, subtract this mini from this. Now I have to uh, calculate the current value now. Before that, I have to check the case for -1. -1 will be the answer if there exists a element which is 0, right? I can handle this case, this test case for this problem. Yeah. If while taking input, if there is an array which is, there is an element which is 0, I have to print -1 and return 0. Yes, this will handle the -1 case. Let's now build the. Okay. So initially the current will be 1. Let's now iterate to the map. It belongs to frequency. Yes. For j is equals to 0, j less than it dot second, j plus plus, current is equals to current into it dot first, and I have to take mod with 10. After all these steps, I have to return current. Let's run the code. Compilation error. Oh, there is small mistake in header. Let's now run the code. See whether it gets accepted or not. Yeah, it got accepted. Let's now go to the wait, let's go to this problem 3, which is bubbles. Before going to this problem, I would suggest you to go to lead code and try to solve the problem, which is, I guess, burst balloons, something like this. This problem is based on that idea only. You can say that this burst balloon problem of lead code can be the prerequisite for this problem. Okay, let's read the problem now. You are given n bubbles index from 0 to n minus 1, and each bubble is painted with a number present on it. Okay, so nums of I is the paint value of that particular bubble, and if you burst ith bubble, you will get nums of I minus 1, nums of I, and nums of I plus 1 coins, this product value. Okay, and if I minus 1 or I plus 1 goes out of bounds, treat is as it is painted with 1. Okay, basically it is saying that if I am having these many bubbles, or yeah, bubbles, and every bubble is assigned a paint value, let's say some x, y, z, alpha, beta, and if at particular step, let's say I am bursting this particular bubble, the coins I will get is y into z into alpha. That is that the nums of I minus 1 into nums of I into nums of I plus 1. Okay. And the question is saying we have to maximize the coins that I can collect after bursting all the bubbles wisely. Okay. There are t test cases, n bubbles, and the paint values, right? So let's try this problem. So let's see this test case where I'm having this particular array 3158. 3158. So at the end I have to burst all these balloons, or you can say bubbles, but you can see that the sequence does matters. Let's say if I am bursting this 3 first. First of all, if the index of the balloon or bubble I am bursting is at the leftmost or the rightmost index, in that particular scenario I have to treat that I have to visualize that there is a bubble present at left or right which are painted with 1, just to make the formula generalize a general formula, because in this, if the I is this particular 0, then I minus 1 is minus 1, which is not possible. So to remove those particular kind of situations, uh, to handle these cases, we have to add these 1 at leftmost point and rightmost end. So let's say I am bursting this 1 first, this 3 first. I will get cost of 1 into 3 into 1, which is 3, plus, so after bursting this I will get 158 as the remaining array. Let's say at this step I am bursting this 5, So I will get cost 1 times 5 times 8, which is 40. After bursting 5, I will be having 1 and 8 only, right? So at this step, I can burst 8, I can burst 1. Let's say I'm bursting 8, so I will get cost of 1 times 8 times 1, which is 8. So after this, I will be having only 1 left with me. So I have to burst this 1. After bursting 1, I will be having cost 1 times 1 times 1, which is. So if I am following this sequence, let's now give indexes. This is index 1, this is index 2, 3, 4 and 5. So I, in this particular step part, I am following this particular sequence where where I have burst the first balloon or bubble, what you can say first. After that, I bursted uh, 5, which is index 3. After that, I bursted index 4. After that, I have bursted bubble present at index 2. So if I have followed this sequence, the cost what I will get is 40 plus 8, 48, 51, 52. I will get 52 as cost, right? Let's somehow change this particular sequence. Let's say uh, I will follow this particular sequence. After 1, I will burst 3. And after 3, I will burst the bubble present at index 2. Then I will burst the bubble present at 4. Let's see what can be the cost for this case. So initially 3, 1, 5, 8 was the given array. I have added extra ones. First one, this first. So I will get 3 as cost plus. After that, I have to burst this 5. I will get 1 times 5 times 8. So 40. And then do indexing first. After that, I have bursted the second index, which is this. So for this, the left one is 1, right one is 8. So the product will be 8 plus 8. After that, I have bursted this 8, 1 times 8. So the final cost for this sequence will be 3 plus 40, 43 plus 8, 51 and then 59. You can see as the sequence of bursting changes, the cost also changes. In the previous sequence, I was having cost 52, and and in this kind of sequence, I am having this cost 59. But in the particular in the question given, I have to maximize the cost, so I have to follow a sequence that will give me the maximum cost. And you can see that the constraints are there are 200 test cases at most. N is up to 200 and value of array is up to 100. Okay, so this kind of question I can solve using DP because uh, I have followed the same sequence up to this step 1 and 3. 1 and 3 is same. After that, uh, I have swapped the positions of this 2 index and 4th index, and you can see the cost changes. But uh, you can observe that this part 1 2 3 and 1 2 3, which is giving me this cost 3 plus 40, 3 plus 40, which is same. So you can see that there are several overlapping subproblems in this particular problem. So whenever we are having overlapping subproblems, we are good to go with DP. So as we know that we are going to solve this problem with DP, let's try to create the DP state. Let's say I am saying let's just by hit and trial I am saying let's say DP of L to R. In this particular DP state, I will be storing the max coins I can earn from this particular interval of indexes L to R. Okay, I have to maximize this, and dp of lr is stating that dp of lr is storing the maximum coins I can earn from a of L to a of R. Even vector is a only, or bubbles nums only, basically from nums of L to nums of R, right? Okay, I have to maximize this thing. So I have created the dp state. Let's now think about some kind of base cases. If L is greater than R, that means there is no particular subproblem existing. Basically, as I am considering this kind of interval where L is at left and R is at right, if L is moving in this direction, when L exceeds this R and L is at this position, then there is not a, in this particular scene, you can say interval will not form. So I will not be earning any kind of, I will not be earning any coins. So for this particular case, dp of lr will be 0, right? Now I have to decide whether I have which bubble I should burst first. So I am having this particular interval L to R. This is L, this is R. I can decide any index. Let's say I am saying this particular index as K, and I am bursting this particular index. So this particular operation will give me nums of K minus 1 times nums of K times nums of K plus 1 coins. But after bursting this, you can say I can divide the subproblems in this particular scenario where this index is K minus 1 and this index is K plus 1. Plus, so let's say I'm uh, creating a recurrence relation f of L comma R as this plus f of L to K minus 1 plus f of K plus 1 to R. But if you know some uh, basic stuff about dp, in this particular interval dp, like you are familiar with matrix chain multiplication problem and some interval dp problems as well, where this is the framework which we use generally. We are having this particular interval L to R, and we have to partition this particular interval about some index p, which will cost us something like cost of p or something. And after that, we will divide. We generally divide this particular subproblem L to R in two smaller subproblems, one from L to p minus 1 and one subproblem from p plus 1 to R. Yeah, but there is a catch in these particular types of problems. Why we are able to divide these complete L to R subproblem into these two subproblems, L to p minus 1 and p plus 1 to R. We are able to divide this subproblem L to R into these two subproblems if and only if these two subproblems are independent of each other. But if let's see, in this particular given problem, if I am bursting this kth index balloon or bubble, both these the left subarray and the right subarray are intersecting. You can say, like, let me take an example. Yeah, when I was having 3, 1, 5 and 8 as the given array, after bursting this particular balloon, the next array will be 3, 5, 8, right? For this particular index, uh, for this particular element present at this index, where there is 3, the left one is 1 but the right one is 5. But if you can interrelate both these problems with this, if this is the particular index about which I am doing partition, let's say this is the k, this is the part and this is the right part, this should be independent of this. But for this particular number 3, the left element which will come into which will contribute in the cost part is 1, but for the right part which will contribute in cost, or you can say the coins, will be 5. But this 5 is a part of right subproblem. That means I can't formulate this type of a DP where I am having L2R interval and I am uh, trying to maximize the number of coins which I can earn in this interval after doing some kind of partition, where P is the first bubble I am bursting in this interval. So I can't do this kind of thing. Let's now try to change the DP state somewhat. Before changing DP state, uh, let's go to the, where is this? Yeah, let's go to this 3158 example again. After hit and trial, I got to know that the sequence which I have to follow to maximize the number of coins in this particular test case is, I have to first burst the 1 which is present at second index, then I have to burst 5 which is present at third index, then I have to burst 3 which is present at first index, and then I have to burst 8 which is present at fourth index. So this is the particular sequence which I have to follow to have maximum number of coins after bursting all the elements of this array. Let's see how. So 1 and 1 are present here. Let's do indexing 0, 1, 2, 3, 4, 5, right? So uh, first I have to burst 2. I bursted this. The coins I will get is 3 times 1 times 5 plus, after bursting this toth index, I will be having this array 3, 5, 8, 1, 1. And after this, I have to burst the third index, which is 5. After bursting 5, I will earn 3 times 5 times 8 number of coins. And after this, I will be having this array 3, comma 8, comma now. And at third, I have to burst the first balloon. I have to burst 3. So I will get 1 times 3 times 8 cost, or you can say coins. After this, I will be having 8, 1, 1. And after bursting this, I will be having nothing and having cost of 1 times 8 times 1. Let's quickly evaluate this. This will be 3 times 5 is 15, and 3 times 5 times 8, 15, 8 is to 120, plus this is 24, and this is 8. This is 135 plus 8, 143, plus 24 is 167, which is the maximum number of coins which I can earn after bursting all these bubbles. We can verify this. Yeah. So after following this particular sequence, I'm getting this particular number of coins which I will earn. But while following this sequence, I have observed that while if I am able to change the DP state as DP of L of L comma R, as the maximum number of coins that I can earn in this particular interval L to R, right? And I will partition about index P, where nums of P is the last bubble I will burst. I have changed the DP state somewhat. In this new DP state, I am not considering I'm not partitioning about the first bubble that is bursted. I am partitioning about P, which is the last bubble which I will burst. So let's try to understand this DP state more with this example again. At last, okay. So let's see. In this DP, in this particular array, yeah, if this is the DP state, then the final subproblem should be DP of 1 to n, because I have already appended 1 at both the ends. So the indexes which the intervals should be from 1 to n. This should be the final subproblem, right? You can see that I can break this subproblem as, because I am partitioning about the last bubble burst. And the last bubble burst is 8, right? For 8, the cost is 1 into 1 into 8. This is what? These ones are out of bounds for this L and R, because you can see this. If this is the array, these are the ones which I have added externally, and this was the indexing, and I am considering this particular subproblem as the final subproblem, right? TP of 1 to n, where n is 4. So the last element which I have busted is 8. And for this 8, the contribution in the number of coins should be 1 times 8 times 1, where this 8 is nums of that particular partition index. This one is present at the left of left index, and this one is present at the right of right index, right? So you can see that I will break this DP state as uh, nums of L minus 1 times nums of this partition index times nums of R plus 1 plus. After this, I can say that I have to handle just this thing. 1 to, 1 to partition minus 1 plus dp of partition plus 1 to n. Now after this step, you can ask me that how these dp states are independent of each other, both these subproblems. You can check, because as for this particular L and R, I'm at this L and R, this is the L, this is the R, and this is the P, 8, right? So after this 8, after busting this 8, I will be having this particular subarray, 3, 1 and 5, right? Where this is the left subproblem and the right subproblem is this one only, right? You can see. And I am not considering cost for this one. After I am just considering cost for this. And again, after this, before, yeah, I will partition about 3. 3 is also at the leftmost point. So we can see that both these subproblems are independent of each other. Let's now quickly try to create transition for this. dp of L to R is equals to, I have to check for all partition indexes, is equals to nums of L minus 1 times nums of R plus 1 times not r plus 1. This should be first nums of p multiplied with nums of r plus 1 plus dp of L2 partition minus 1 plus dp of partition plus 1 to r. By this particular dp state, I can uh, break this dp state into two smaller subproblems, two smaller dp states, which are independent of each other. Why these are independent of each other? Because at each step, I am removing either this particular balloon or bubble, or I am bursting this particular bubble. Because I am bursting the balloon present at the last, at the ends, after bursting, the new subproblems will be something like this. I have bursted this part, or I have bursted this part, which are independent of each other, because this part is independent of this part, because I am not considering coins from this part. So I'm just considering this. And for each element, the I minus 1 and I plus 1 are not in the other subproblem. So these are independent of each other. I can do this particular transition. Before coding this problem, let's try to uh, analyze its time complexity and space complexity. Uh, Number of states for this problem is L will go up to 0 to uh, N. This will also go up to 0 to N. So number of states are N square, whereas number of transition is L2R, which will go up to big of N at most. So the overall time complexity for this is number of states times 1 plus number of transition, which is big O of N cube. This is the time complexity for this DP problem. Let's now discuss the space complexity for this DP problem. This will be big of N square because I am using 2D DP. Let's now quickly code this DP problem now. Yeah. So hash include bits forward slash stdc plus plus dot h using namespace f long ln. There are test cases also for this problem. So in t is equals to 1, c in t, while t minus, while t minus minus, c in n, a of n, c in array of I, or you can say nums. Let's say nums, right? Yeah. So nums. After this step, I have to uh, in this particular problem, I will use memoization in place of tabulation. If you want, you can do tabulation also, the iterative code. But in this problem, I will be using the recursive code. So let's now create the function for this, which will return the maximum number of coins. It will take two inputs. Recursion. I am using the lambda function for this. LR pruning base case cache check, which will be for which I will use for memoization. Compute state, save and return. Let's now, if L is greater than R, then in that scenario I will not be earning any kind of coins, so return 0. because for L greater than R there is no subproblem existing. Actually, the answer value should be 0. I have to partition. P goes from L to P goes till R, right? Yep. So yeah, cost, not cost, the coins I will earn, coins, is equals to nums of P, nums of L minus 1 times nums of P, which I have already discussed, nums of R plus 1. This will be the cost for this particular partition bursting, plus recursion of L2 partition minus 1 plus recursion of partition plus 1 to R. This is the particular cost, and answer will be max of answer comma this coins, and I can return this, return answer, return cout recursion of 1 to n, which is the final sub problem. Let's now run this code. If there is some error or not, there is compilation error. Why? Log int. I guess I have used int somewhere. Let's tell this lambda function that it will be returning long. And so why? Wait a second. Test cases, this. Let me check. I guess there is some error. Yeah, I forgot to append the ones at both the ends. It should be n plus 2. I should be appending nums dot pushback 1. It should be from 1 to n. And after this, nums dot pushback 1. Let's now quickly run the code. So again, it is giving me wrong. Let's see why. Vector n plus 2 size. Yeah, it was a small mistake of DP. Let's now run this code. It should accept. It is running. Yeah, it got accepted. You can see that after doing this, actually at that time I forgot to write this memorization step. I have created this DP array of maximum size, and I've used memset for each particular test case, and I've used this memorization step. If dp of l comma r is not -1, I have directly returned dp of l comma r, because I have already calculated that sub problem. That's all for today's video. If you are having any kind of doubt, please you can ask in comment sections. Thanks for watching.